All right, today we're going to talk about simplifying radicals. Radicals is the symbol. We've talked about this a little bit last week. This is not divided by 2. This is common mistake that we will often do just because it does resemble the divided by 2. The parts of this are called the index, which is the part I have marked there. And this is the radical. The actual symbol is called the radical. And then the value underneath is called a radicand. So when we use any of these words, that's what we will talk about. We're going to stick to the square roots. I have a few examples that have fourth root stuff. That's just for you to look at, but we will not be doing anything higher than a square root today. And we'll also talk about those variables. So as we take a look at this, we're asked to take the square root of 20. Now 20 does not have a perfect root. We can get an estimate of where the square root of 20 is, but we cannot give it an exact number because it doesn't have a perfect root. So what we're going to end up with is an irrational number. So what we can do instead is break out any part of 20 that has a perfect root. If you're good at recognizing this because your factoring skills or your multiplication skills are a little stronger, that's great. I'm going to show you another way we can do this if possibly you are not. But if we look at this, our values again that have a perfect root were 1, of course, but we won't deal with that. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 is 25. 36. 49. 64. 81, and then 100. Obviously, there's more than that, but that's values 2 through 10. So as we look at this number, we're going to see if any of these values go into 20, and we hopefully recognize that 4 times 5 is 20. So we're going to rewrite this as opposed to saying the square root of 20, we're going to write it as the square root of 4 times 5. Now, the way that radicals work, we can split this into 2 separate radicals, the square root of 4 times the square root of 5, and this is still equivalent to the square root of 20 that we saw at the beginning. Now, when we split these, what this allows us to do is take the square root of the number 4, which does have a perfect root, and the square root of 4 is 2. Now we do, and tonight's homework, we're not going to worry about this, but when we start talking about the quadratic formula, we will be dealing with plus and minus values. But for today, we're just going to do the positive roots. So the square root of 4 is 2, and 5 does not have a perfect root, so we're going to leave it alone. So the square root of 20 can be simplified down to 2 times the square root of 5. I am going to go over more examples like the last, but I want to go through the 3 different types we're going to see for those of you that catch on quickly and you want to go ahead and get working on your assignment. I've actually set up the 3 different types that we're going to see. So this is a negative radicand. Now there is no solution to these, but in Algebra 2, and we might have seen this in Algebra 1, we've created imaginary solutions. And basically it's saying, okay, we recognize there is no solution, but what if? What if there was a way to simplify this? And the way that we do the what if is we factor out a negative 1. So you need to write this down in your notes. The square root of negative 1 is written as I, the imaginary number. So when we have the square root of a negative number, we're going to have an imaginary solution. So the way we go about this, I'm going to do this one time, and then on the later examples, I'll show you how I do it in a quicker way. But I want to make sure that we have everything written out. We're going to change this to the square root of negative 1 times the square root of 125. So 25 is a perfect root that goes into this. And another way you can look at this when you deal with 25s is think about quarters. If it's $1.25, how many quarters does it make to make $1.25? Well, that would be 5 quarters. So I'm going to go ahead and change my 125 to the square root of 25, because that's the number that has the perfect root, times the square root of 5. Because 5 times 25 is 125. And we'll go ahead and change the square root of -1 to I, which is our imaginary number. We take the square root of our 25, which is 5. And we have the I already sitting out there, so we are going to just attach the I to the 5. And then all we do is tack the square root of 5 onto the end. And the simplified form of negative square root of 125 is 5I times the square root of 5. All right, I do have some more examples, but this kind of wraps up the 3 different types that we're going to see. We had the square root that just needed to be simplified. Then we had the negative radicand, and now we're going to put a variable in the radicand. So first off, the square root of 25 is 5. So we're going to go ahead and take care of that. That's going to be on the outside, and then our radical will still be there. Now, when you think of these x values, whatever the index is, these will escape to the outside in that many increments. So this is a square root, so they're going to escape in pairs. We have x to the 11th power, so that's going to be x 11 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is x to the 11th power. So we're not going to do this every time. This is just an illustration for the first time. But they will escape in pairs. Since we have an odd number, we know that everything is not going to pair out. So we will have an x left over. Now, you'll never have more than one x left over, because if you did, you should pair out another. So we are going to count the number of x's that pair out. So we have 1 pair, 2, 3, 4, and 5 pairs of x's. And then you can see our lonely little x out here that did not get a pair. Well, our 5 x's that paired out get to join the 5, because the square root of x squared is x. So this is a single x on the outside, single x on the outside, and you see we get 5 independent x's, so it's going to be x to the 5th power. Now the 25 cleared out completely because it was a perfect root, but our x's did not. We had the 1x left in there by itself, so this answer is going to be 5x to the 5th power times the square root of x. Now, this is also something that can be put into your calculator to check your answer. You could go y1 equals this and y2 equals that, and your 2 answers should have identical tables. If you're having issues with these, keep that in mind. Graph often. All right, if you want to work ahead, you can. Those are the 3 types that we will see. I've got a couple of different ones, but except for the process for solving these will all be the same. So if you're still struggling, no worries. We're going to take a look at a few more examples. I think we have 6 more. So if you're not as good with your factors, well, our factors of 80 that have a perfect root, I can think of 4 off the top of my head. And if you don't factor completely, like 4, there's one higher than 4. I believe it's 16. But here's another method we could do in order to do this. Whether it was the factoring tree, the birthday cake, however you were taught to factor these, what it's called is prime factoring. So 80 is 8 times 10. The closer the numbers are, the more symmetric your tree is going to be. I mean, there's no rule on that, but just so you know. So this factors down to this, and the 4 factors down to 2 and 2. All right, so why we would do this is because whatever pairs out gets out. So we have prime factors of, and I would not write these every time. I'm just showing it for your benefit. 80 is 2 times 2, times 2 times 2 times 5. And just like when we talked about the variables, these get to escape in pairs. We have a pair of 2's and we have a second pair of 2's. So the way that this goes is on the, here's our radical. We have a 5 that got left inside. So we're going to go ahead and put that in there before we forget about it. And on the outside, we had a 2 that gets to go out. And then we get another pair of 2's that get to go out. So this goes out to the outside, and notice it is multiplication. So 2 times 2 is 4 times the square root of 5. So the simplified form of the square root of 80 is 4 times the square root of 5. You don't even have to go to y equals on these. These are irrational numbers, but the square root of 80, if you put that in your calculator, the square root of 80, and hit enter, you're going to get the same exact number as if you put in 4 square root of 5. This is something you should do. This takes 8 seconds to put into your calculator and check your answer. It's silly not to do this. So make sure that you do put this in your calculator and check your answers. On this problem, we could do the same thing and break the 96 down into the factoring tree. And this would work perfectly fine. I mean, I think 3 times 32 is a number, 8 times 4, and we could keep breaking this down. By the way, if you were going to do it this way, don't break these 4s down. If you notice the 4 matches, just take care of that. I want to show you another trick. I've always got calculator tricks. Well, here's mine. This one is really good. Really good. Even if you are working ahead, it may be worth your time to stop and see this trick that I have. So what I do is I go to my calculator and I type in y equals. Notice how often I do y equals stuff, right? 96 divided by x squared. 96 divided by x squared. This is actually just going to give me the answer. So when I put this in my calculator, I'm going to go ahead and put my radical here. What you need to know is the value. What we're looking for is integers. What we're looking for is integers in the table. So we hit second table. We're going to look for the integers. And if we have a matching x and y integer, that's where we put them. So if we look at the table for the x values, it actually has a couple of answers that work. And we obviously want to use the largest one. We're going to skip 1, obviously. 1 is a waste of time. But we see 2 and 24. 3 is a decimal. 4 and 6. And then if you look for the rest of the table, it's just a bunch of decimals. There's actually an 8 and 1.5, but again, that's still a decimal. So technically, there are 2 answers to this. But it does say the simplest form. So the one that is furthest down the list is the most simplified version of the answer. So if we were taking an EOC, where we have something where we have multiple answers, 2 square root of 24 is a factored form, simplified form. It's just not the best one. And the best one would be 4 square root 6. And again, where I get this from, the x value will go in front of the radical. The y value will go inside. And again, put this in your calculator. You're going to get an irrational number. Put that in your calculator. You should get the identical irrational number. It's a nice little trick. All right, we're back to the negative radicand. This one is actually really quick and easy. Like I told you, I'm going to show you the way that I do these. I do not actually factor out a negative square root of -1. If I see a negative sign, I kick it to the outside and then just call it I. I don't overcomplicate things. That's what it is. That's what I'm going to do. So as I look at square root of 6, 6 does not have a perfect root, and it doesn't have a factor that has a perfect root. So this is the simplest form. All right, so as we take a look at this one, again, I'm going to just take care of this negative sign. I'm not going to bother with anything like that. I'm just going to simplify it this way. I'm not going to do two steps. I'm kicking out to the side, and it's an I, and then I move on. Now I'm going to do the factoring tree. I would definitely do this in my calculator just because it's faster and it's really a safer answer. But those of you that may not have one or just don't trust them yet, hopefully by the end of the year you will. 108 is 9 times 12. And if we keep breaking this down, 9 is 3 times 3. 12 is 4 times 3. And our 4 is going to break down to 2 times 2. So we go through and we look for everything that pairs out. Well, I have a pair of 3s and I have a pair of 2s. And then I've got a 3 left all by itself. So what we're going to do now is move the 3 out to join the I. And we're also going to move the 2 out. And this turns into multiplication for both of these. And then we also have the 3 that did not pair, this one right here, that is left inside. So the simplest form for this would be 2 times 3, which is 6i to the third power. You actually could check this in your calculator as well if you just left out the negative sign and then left out the I. Those numbers should also match. It's not exactly the same thing, but if you handle your I's correctly, then that will work as well. And the last things we're going to talk about are, again, these variables. You should always know that if there's an odd number, you're always going to have an X left. So when I look at this, I know this is going to be left with a single X in here. Because as these 7 X's stack up here, they're escaping in pairs. So if you have an odd number, everything can't pair out. You do not need to write these out. But if you need to, you write them. But I'm not going to say, well, where are your X's? But I have 1 pair of X's, 2 pair of X's, and 3 pair of X's. That is not 3x. That is x to the third power, because remember, these are multiplying. So I'm going to be moving 3 x's, x to the third power, to the outside. So this is how the square root of 7 would look. But let's not forget, we already had an x sitting out there waiting for this one. So what we end up with is x times x to the third, which is x to the fourth power, times the square root of x. And this is the simplest form. Again, y1, y2, and their tables should match identically. I really think this is something you guys should do until you get better at these things. Even when you do get better, what's it hurt? It just takes a few extra seconds. And our last example, not that this is any harder, just showing you that sometimes the variables, there's nothing to pair out. And there are times if you have an even number, if this was a 2, everything is coming out. There should be no variables left inside. But on this, our x has nowhere to go. So it has to stay in there because nothing pairs out. But we are going to you hear me say this all throughout the year. Numbers do what they're supposed to do. So the square root of 4 is 2. It's just a matter of remembering that 2 goes on the outside. Here's one of my concerns. I'll see students do this all the time. When you take the square, that's the answer, by the way. Go ahead and plug that in. We're going to move to another screen. I want to continue the thought that I just had. One of my concerns is the reuse of a radical. Here's an example. This is the most common example I see this. The square root of 81 is 9. Period. We do not reuse radicals. Here's what I'll see people do. It's such a common thing. I feel I need to point this out. I will see people, I'll write this in red because this is a no. Stop doing this. I will see somebody say the square root of 81 is the square root of 9. And then they'll go one step further and end up saying the square root of 9 is 3. So when it all comes out, what they're saying is the square root of 81 is 3. But remember, that square root sign does not, once you've performed the operation, it's done with those numbers. I know that it stuck around on a lot of our examples, but the reason why that stuck around is because we used it in full. So it's not going to follow the number that has already received the square root. All right, you guys have your Delta Math assignment. Good luck.